In the last video, some of you in the comment section couldn't help but notice something irrational.
What the hell?
What was that? Well, welcome back. If you're new, you're welcome. My name is Ajibolo Taiwo from Genius Breeders, and we'll make videos like this every week, where we'll bring basic skill and knowledge that you need to excel in whatever field that you are. So subscribe to this channel if you haven't done so. If you have, let's get right into it in a jiffy. So as I mentioned earlier, we have what we call irrational numbers, just as we've seen in the last video. I also said that all these numbers are under what is called real numbers. Real numbers consist of natural numbers, integers, and today we'll be considering the remaining two rational numbers and irrational numbers. Somehow, these words sound so alike, so I'll do my best to make it clear. So, rational numbers and irrational numbers. Rational numbers are denoted by the letter Q. They are numbers that can be expressed as a fraction. For example, we have 1 over 2, 2 over 3, 10 over 3, and so on. Now, these can be converted to decimals. So 1 over 2 can be converted to 0.5. 2 over 3 can be converted to 0.666, and so on and so forth. It's a recurring decimal. And this can be converted to 3.333, also a recurring decimal. I made a video on how to convert fractions to decimals, so please check it out using the link up here if you haven't. Now, irrational numbers, on the other hand, are denoted by the letter H. They are very interesting. From the name, we can tell that they have something opposite but related to rational number in the aspect of how they are written as a fraction and a decimal. However, in the case of irrational numbers, they can only be expressed as decimal but not as a fraction. They can be expressed as fractions, but they can be expressed as decimals. Now, this is very interesting, right? We're used to decimals coming from fraction, so it seems impossible to imagine them coming out of nowhere. Sounds very irrational indeed, isn't it? You most likely have come across irrational numbers, but you never knew. A classic example is the pi. I'm sure you want to protest that pi is equals to 22 over 7 as a fraction, but I kid you not, it is not absolutely correct. Pi is just conveniently used as 22 over 7 in order to make it easier for us to calculate, especially in areas of circles and so on.
Yeah, that makes sense.
Pi is actually a decimal that never stops as a terminal decimal or recurring decimal. It continues on and on without stopping. In fact, to give you a good perspective of what pi really is, I went online to find out what the full value of pi is. And here you go. This is just the 100,000 digits of pi. It continues more than that. So it goes by saying you have 3.14159265358 down to continues. I'm still scrolling down, I'm still scrolling down, and that's it. And that is where they decide to stop. And it continues on and on. Pi is a very important value in calculations, especially when we're calculating areas of a circle. Calculations that involve circles uses pi a lot. And I would like to show you how it is done on a calculator. So on a scientific calculator, you usually have your pi as a second function of the exp button, and this is what we mean. This is the exp button here. So you want to generate the pi value, you simply press the shift button and the exp. So this is it, press shift and exp. So you have the pi right here, and if you look at it, we have 3.14159265359. And we go to another example of irrational numbers, that are also very important. In fact, they are radical set. And what are they? They are square roots of numbers that are not perfect number. Meanwhile, I did a video of perfect squares and their square roots, so you might want to check it out. Now, the square root of numbers that are not perfect square are irrational numbers. Why do we say so? 2 is not a perfect square, so we have square root of 2, we have square root of 3, as 3 is not a perfect square. You can also call them, instead of saying square root of 2, square root of 3, that can be very mouthful. So we can just say root 2, root 3 is acceptable. And root 4, no, 4 is a perfect square, so it's not inclusive. We have root 5, root 7, and so on and so forth. So remember that the one very property of irrational numbers is that they cannot be expressed as fractions, and their decimals are neither terminal nor are they recurring. They just continue on and on. Random numbers that come out in random manners. And how do we know that? If we bring out our calculator and we press root 2 and we find out the answer, press root, we press root, the symbol of root is right here, and we put in the 2 into that symbol, we have our answer here. So we have 1.41421356,237. So let me copy it out and just paste it here. So that's root 2. Let's find out root 3. So all I just need to do is to delete the 2 there and put my 3 there, and we have our answer coming out immediately as 1.73205080757. We go on to root 5. We have this 2.23606797775, and root 7 finally we have 2.64575131106. So there you have it. Look at the trend of these decimal numbers. You have it occurring in a random manner. There's nothing reoccurring, there's nothing repeating, and there is no terminal. It continues on and on. This is just an approximate value. Radical numbers are very, very important in mathematics, and a video on how they are used in calculations will be made soon. Please watch out for it. So, as a summary, we've learned about 4 different kinds of numbers. We've learned about natural numbers denoted by n. We've also learned about integers denoted by z. We've learned about rational numbers denoted by q, irrational numbers denoted by h. All these numbers can be represented on a number line. How do I mean? So if we have a number line, 0, as we said, belong to integers. Starting from beginning, the natural numbers, examples of them include your counting numbers is 1, 2, 3, 4, and so on. Integers include these positive numbers, which are the counting numbers, 0 and their negatives, -1, -2, -3, -4. By way of coding it in this green color that I use for integers, we have all these numbers here drawn as integers. For our rational numbers, we've considered 0.5, 0.666, 3.333, and so on and so forth. So we can find our 0.5 somewhere here, and we can also find our 0.66 here. And now for irrational numbers. So as I said, root 2 is 1.414. So 1.414 will be found here. That's root 2, and root 5 will be found somewhere here on the number line. So it can be interesting to see that all these numbers can be represented on a number line. Now, if I could read your mind, you'll be wondering if I forgot to talk about odd numbers, even numbers, and prime numbers. These numbers are actually properties of integers and natural numbers. So they are not classes of real numbers, but they are properties of these numbers that we've talked about. And we're going to talk about it in the next video. Until then, please feel free to drop your comments, and don't forget to like this video, subscribe, and keep your notifications on if you haven't done so.